All right, let's take a look at this example. On this one, we've got dx over x squared times square root of x squared minus 16. So if you look at this, we've got variable minus constant. So that means we're going to be in this situation here. Now my variable in this case, x, so I've got u equals x and a equals 4. So we're going to use this, and the substitution we're going to use is x equals 4 secant theta. All right, so if x is 4 secant theta, dx is going to be 4. Derivative of secant is secant theta tan theta. D theta. I'm not going to draw my box yet because I want to do my radical. X squared minus 16. Let's see, x squared here is 16 secant squared theta minus 16. That's equal to, let's see, pull out the 16 to the outside, you get 4. Then you're left with secant squared theta minus 1. So that's 4 times tan squared theta under the radical. So you get 4 tan theta. All right, so this is all my substitution stuff. So my integral up here is equal to, and I've got to replace each one of these things. And I've got a typo on here. This has an extra dx. This one on here shouldn't be here. You should only have one differential. All right, so my dx on top, that gets replaced with 4 secant theta tan theta d theta. And on the bottom, x squared gets replaced with 16 secant squared. And the radical gets replaced with 4 tan theta. All right, so now we've done all of our substitutions. We've just got to simplify and then deal with the integral that's left over. So let's see, I can cancel some of this. The 4's will cancel. This tan cancels with that tan. This secant cancels with one of those. This turns into actually a really nice integral, because we get integral of, let's see, nothing's left on top except for d theta. And on bottom, we're left with 16 secant theta. Well, I can pull that out front and have 1/16 integral of secant is on the bottom, so we're dividing by secant. That's the same thing as multiplying by cosine. Maybe I should have made this the first example instead of the other one, because this turns into an integral that's a piece of cake. What do you get when you integrate cosine? You get sine. So you get 1/16 sine theta plus c. We've got to put this back in terms of x. So I'm going to draw a triangle, and I'm going to do that over here to the side. All right, so I'm just going to pick this to be theta, and x equals 4 secant theta. So if you take x equals 4 secant theta, you can rewrite that as secant theta is x over 4, or cosine theta is 4 over x. Now remember, cosine is adjacent over hypotenuse, so that means my adjacent side is 4, my hypotenuse is x, and that makes this side over here x squared minus 16 under the radical. So I can pull my sine straight off of here. Sine of theta, just read off the triangle, is going to be opposite over hypotenuse. So I'm just going to come back up here and write that in, and that's our answer. This was a significantly nicer problem than the first example. So we'll